Hey, how you doing? Welcome to Let's Get String. This is Chaser Revolo. I'm just kidding. This is Let's Get String. So this video is about me doing a fun little experiment. I'm comparing the differences between all these cheap scales and this Dr. Meter over here that I've been using all along, which one of the viewers has complained that I trust my $1,000 machine with a $10 cheap scale. So in order to see how close all these cheap scales are relative to each other, so I bought a couple more of them. I bought an identical one here, another Dr. Meter, as well as a portable electronic scale. Got this fish scale that I got Walmart. I don't like the way it's set up. It's it's meant to be held in the hand, so for the time being, I'm not gonna mess with this one. So far, as I'm progressing, what I did was I've already weighted one of the dumbbell weight is marked as 15 pounds, but on my kitchen scale, which I weighed, it was 14 pounds and 11 ounces. And I just used this piece of wire to be able to hang it off with a scale in order to measure it. The weight of this string is about 2 grams, so I consider that negligible. So yeah, there's about 28 grams in an ounce, so a piece of wire that weighs 2 grams, I consider that negligible. Anyway, so that 14 pounds and 11 ounces translates to about 14.7 pounds, according to the kitchen scale that I weighed it. And I repeated it on my original meter. I differentiate these two by a piece of sticker here. The one with the sticker is my original one. I weighted that to be 14.5. And all right, I'm gonna show you what I do as I progress. So just between my kitchen scale and my meter, there's 0.2 pounds worth of difference. I didn't like that. So basically between this one and this one, which one is more accurate? I don't know, since I don't have a golden standard. I mean, we have a known weight in terms of a meter, like one of my other viewers suggested. He did some concoction. He weighed a bucket of water that's worth of several gallons, and he translated that to a certain number of pounds. But then the bucket that he used, that's unknown weight right there. He had to use something to determine the weight of the bucket. So the scale that he uses to weigh the bucket has just as much unknown as any one of my scales. So in order to characterize between these, I'm just let's see how close these two other ones are. All right, hang on. Okay, so this is the new Dr. Meter. I just hung it up here. It's measuring 14.67. Lockout mode is off, so this is the actual live reading. As you can see, if I pull it with my finger some more, it's going to increase the number. As I let go, it goes back to about 14.67. So about 14.7 to make it easier. All right, let's try the next meter. Okay, so I just hung up the same weight onto this new meter without lockout mode turned on. See, just to show you that it's live. All right, I make sure that it's not touching the wall in the back. And we have a reading of 14.49. Call that 14.5. That's in pounds. Okay, next thing I'm gonna do is to check the accuracy on a higher weight pool, around 48 pounds or so. These are in ounces. So what I want to do is add 74 more ounces from these two weights. I just weighed them on my kitchen scale down there, and they're 74 ounces. And then I'll add these two to the three big ones. One that's over there in my concoction, plus two more on the floor. I mean, they each individually they weigh differently. That's why I labeled them in the beginning according to what the kitchen scale showed. But you know, doesn't matter what the difference is between them. It's the total weight that that I'll be measuring. So theoretically, according to my kitchen scale, all these weights will add up to about 48.1 pounds. And I'm going to measure them with each of these. So hang tight. All right, first up is the Dr. Meter, the original, with two pieces of strap. And let's read it. 47.8. This is live reading. If I pull a little bit, it's going to increase. Actually, it's locked out. Let me turn the lockout off. Lockout is off. 47.76. If I pull some more, it increases. Okay. 47.8. Steady. Very stable. Let me go write it down. Okay, next up is the Dr. Meter number 2, which is the new one that I got. And it's currently reading 48.2. Steady. It's not locked out, so that's live reading. If I just pull on it a little bit, it's gonna increase. Just to show you. Display is hard to read. I'm gonna pull on it a little bit. See how it increased to 49. As soon as I let go, backs down to 48.2. All right, let's call it 48.2. And here we got the third meter, which is called the portable electronic scale, hooked up. It's free hanging. It's reading 48.01. Steady, it's not locked out. If I pull on it a little bit, it increases it. I let go. It goes back to 48.01 pounds. Go write it down. So what do we have here? Well, at the lower end, there's a 0.2 pound difference between the 3 meters. And as far as around 48 pounds, we are looking at 0.26 here. 0.26 pounds too low, and this is 0.14 pounds too high. And this one, the portable meter, this one is 0.06 pounds low. So it looks like according to these numbers, the most accurate one is this portable electronic scale. But you know, sometimes air can be introduced when I go and hang my weights. Maybe a little bit of fidgeting around will cause a fraction of a difference with these scales. So that might be a consideration. So I mean, being that when I use the stringer, I could string up to as high as 60 pounds. I'm gonna try and pretty much tag on some more weight. So stay tuned. Okay, so I just added another sub 15 pound weight, and I had to change up my hanger a little bit. My plastic zip tie basically cracked and lost one piece of it, so I had to use this piece of steel wire. Basically just hook it up to here. All right, I have the lockout off. And I have the unit turned to pounds. And I'm at 57.8. There's a lot of weight hanging at one point, so it'll sway for sure. It says 57.8. Okay. If I tear it right now, it should say the opposite when I take it off. Yep, I got it off the hanger, and it said, it was showing 57.8, but now it's back down to 57.72. All right, I'll take that. 0.1 is not big of a deal. Yeah, we'll call it 57.7. I have to figure out what the theoretical is. Be right back. Okay, I went and find out the weight of that new dumbbell that I added. I had it labeled on there. It's 14 pounds and 15 ounces. That translates to 239 ounces plus the same 3 from the previous experiment, 235 plus 228 plus 232, 235, 228, 232. I added all that together and divided by 16 ounces into per pound, and I get 58.4 pounds. So compared to what my meter number 1 is reading, meter number 1 is low by 0.7 of a pound. Yeah. So as you can see, the higher tension that we pulled, these differences will increase. So let's see what the other 2 meters will measure for us. Stay tuned. This is Mr. Meter number 2, hung up with these 4 dumbbells, and it is reading, with no lockout, it's reading 58.4 pounds. All right, I'm gonna go write it down. And lastly, got the same way hung up with meter number 3. And let's see what it's reading. This is 58.3 pounds steady. And as you can see, meter number 2 is dead accurate. 58.4 theoretical, measure 58.4 pounds. Meter number 3 is 0.1 pounds low, which is almost nothing. But my original meter over here has measured 0.7 pounds low. So you know what? Just to double check, I'm going to perform the measurement again with this original meter, see what I get. Hang tight. Here we go. This is the original meter number 1 repeat measurement. This time I make sure that I hit the tear button before I hooked up my hanger wire. And we got 0.1 pounds higher than the previous measurement. So it's now 57.8. Okay. All right. After all that shenanigans, without breaking my back, carrying the hanging the weights and taking them off. Basically, I have 3 sets of measurements, or 6 sets now, or 7 sets, comparing to the theoretical numbers added up based on the kitchen scale measurement. Okay, and when we use one single dumbbell at 14.7 pounds, my original meter, this one here, has measured 0.2 pounds low. Meter number 2, this new one over here, is 14.7. I'm not saying that it's more accurate or less accurate, it's just that they measure the same as the kitchen scale. And the third portable scale over here measured 0.2 pounds lower. So at lower tension or lower weights, I have this maximum delta between all readings being 0.2 pounds. So that's somewhat of a basis, but it doesn't say much until we start going up higher, closer to what we will string our tennis racket at. So I added a couple of more weights to it, totaled up to 48.06 pounds based on my kitchen scale measurement. Where's that scale at? Yeah, that one over there. I'm not saying that's 100% accurate. Now, you might argue that though, you have to calibrate your scale versus some golden standard. Well, I don't have a golden 48-pound standard, so I'm just comparing 4 sets of numbers to see which one happened to be the outlier and which one among the 4 tend to agree with each other more. And as you can see, at 48 pounds, my original meter has once again measured low by 0.26 pounds, close to 0.3 pounds low. And meter number 2 measured 0.14 pounds high. Meter number 3 measured very close. It measured 48 pounds, which is just 0.06 pounds lower than what it's supposed to be, lower than what the kitchen scale measured, not what it's supposed to be. So based on these numbers, my original meter is the outlier. It measured almost 0.3 pounds too low. I mean, when I normally string my racket at 48 pounds to 58 pounds, I can expect that it's this meter. If I calculate based on this meter, when it says 48 pounds here, it's actually, the actual tension is actually higher by 0.3 pounds. Okay. Assuming the kitchen scale is closer to what the actual tension is. Now, plus minus 0.3 pounds, to me, you know, around 48 pounds plus minus 0.2, 0.3 pounds, it's really not that big of a difference in terms of what anybody can feel when they go to hit the ball. I mean, if you're a really good player, you might be able to feel a difference of a couple pounds, or even 1 pound if you're super good, maybe if you're a pro. So down to a half a pound or within a half a pound is really hard for anybody to notice the difference. So I would say at this amount of difference, it's still very hard for anybody to notice. However, in the next experiment, I added more weight to the upper end of what we usually string our racket at, being 58.4 pounds on the kitchen scale. My original meter measured 57.8 pounds. I had to repeat it just to make sure. So it measured once again low by by 0.6 of a pound. Meter number 2 measured the same as the kitchen scale, 58.4. So there's no difference. Meter number 3 measured 58.3 pounds, which is only 0.1 pound lower than the kitchen scale. So these 2 meters almost agreed with the kitchen scale on the upper end of the spectrum. They're very close to the kitchen scale. So the only outlier reading over here, this minus 0.6 pounds low, is from my original meter. So based on this, I would tend to trust these 3 sets of scales, my kitchen scale and these 2 new scales that I just got. So with all that being said, maybe it's time for me to retire my original scale if I'm really being picky, because with it being reading the tensions low by 0.6 of a pound would mean that if I use it to calibrate my machine, my actual tension will be actually 0.6 pounds higher than what the meter says it is. Dr. Meter, my original one, says it is. Assuming if the actual tension is actually closer to my kitchen scale. So that's, you know, interesting, being that I don't have a 58-pound golden standard laying around. You know, I don't have 58 pounds worth of gold or 58 pounds worth of water without any other containers with unknown weights. This is the best I can do, just to sort out which meters are the closest to each other. And in this case, it happens to be that maybe I'll have to start using one of these 2 meters in the future. Maybe I'll keep this one. This luggage scale is what's being sold by major tennis retailers for calibrating racket stringers or something very close to it. Not saying which device is better. There's also digital ones that come with expensive stringers. They make their own. Those may or may not be accurate. I don't know how they're calibrated, just like these. So, and then coming up in the next video, I'm going to compare all my digital meter readings versus this spring device from Gamma. Okay, Gamma Tension Calibrator. This is before people started using the digital meters. People will use this as you pull tension, as you mount it on the stringer. You know, you mount one end over there, and then the numbers end toward the puller, toward the tensioner. This bar will come out, and you can read it either in the pound scale or the kilogram scale. So it'll be interesting to see what this will read when I hang it up to my ceiling beam over there, and I'll show that in the next video coming up, so stay tuned. Thank you very much for watching, and I shall see you next time.